Dan had a question about one of the homework problems, and I thought that there might be value in us talking about it together, but let me talk about something a little bit different. So, let's see, we have an elephant.
Student support services and youth. Yeah, I have, what is it? I was having such a hard time with your, not just yours, but the whole online stuff.
Oh, uh-huh.
Navigating.
Yeah.
So, I've been taking all these little different, like Focus and whatever else.
Right.
I don't know.
Are you pursuing a degree or a certificate?
It's no. I'm doing everything for a certificate.
Okay.
For this semester.
Yeah.
But I'm going to work towards a degree.
But you're declared as a certificate?
No.
Are you declared as a degree?
As a degree.
Then yeah, STEM, the Student Support Services. If you're pursuing a degree, STEM is a great way to go. Science, technology, engineering, and mathematics. I'm
terrible at math, dude.
Well, they offer additional and more intimate, more personal, shall we say?
Then up there.
Tutoring, right. They offer better, what I would call better tutoring. Instead of one tutor for 20 students, it's like one tutor for maybe 3 or 4 students.
There doesn't seem like there's very many people taking advantage of that tutoring anyways.
Okay.
Doesn't matter to me, as long as I get it. Because I need it.
Right. So take this thing with you. Yeah. And they're in the Horizon building.
Yeah, okay.
Yeah, good. So, I have an elephant running up a hill. Let's say here's our hill.
Can I sit down?
Please do, absolutely.
Who's the cat?
That's my dog. Thank you very much.
His name's Killer.
Her name's Hickory.
I have
She's a little joy.
I was looking for a Great Dane and I got a free poodle palm.
Oh my. Oh my. One of your classmates, Dolores, she wants a, what do you call those, pocket pigs?
Yeah.
Oh yeah, I want one of
What are
those.
I don't know what they're called, but she wants, yeah.
We got a Chihuahua Pekingese, Chickapoo or whatever.
That's
Whatever it is.
crazy insane. So let's say that this elephant is running up this hill at, let's say we'll make it easy, 5 meters per second.
Right.
Okay, so this is his velocity.
Right.
And we'll say that the change in height is 20 meters.
Right.
And we'll say that the elephant weighs, he has a mass of 1,000 kilograms. The first thing I want to point out is that mass is not the same as weight. How do we define weight in this textbook?
Gravity, right?
There's a gravity component. We can say that weight equals mass times gravity. In other words, W equals mg. So to your comment, Dan, you say that the potential energy is weight times height.
That's what the book says.
Sure, and that's strictly speaking true, because if you look at the equation that I gave, it's mass times gravity times height. But you need to consider, are they giving you the weight or are they giving you the mass in a problem?
Well, you gave me the weight. You gave me the 1,000 kg.
Okay, but a kilogram is not a weight. A kilogram is a unit of mass.
Oh, okay.
So there's that to consider. So we could ask the question, the 2 questions really. One, what is the elephant's kinetic energy as it's running up the hill? And 2, what is its potential energy when it gets to the top? So, I don't know, orange is good, I guess. So what's the equation for kinetic energy?
I don't know.
Okay. Do you have your book handy?
It's in my backpack.
Okay.
It's 1/2.
Where are you finding it?
It's right here, page 10.
Page 10.
But something that I should probably tell you that will help you understand where I'm at
Yes, sir.
with all this stuff. That AccuPlacer test,
Uh-huh.
it just reads on based off of what you put in there,
Okay.
and it gives you multiple choices.
Okay.
When it comes to algebra,
To processing this way?
I just picked the best answer off of what was going on up top.
Yeah.
I don't understand it
Okay.
yet.
Okay.
That's why I'm going to take tutoring stuff, because
Okay.
it's.
People process information differently. People store information
And I
differently.
like the way you teach. You're doing good.
Oh, well,
But
thank
I
you.
just don't. I don't understand everything.
Clint, we together are embarking on a journey. We're going to have a good time.
Damn right.
So Dan says on page 10, we will find the equation for kinetic energy.
Okay. Got it. Yeah. Ke equals. I would say a half.
Yeah,
Uh-huh.
it is. It's 1/2 times.
I'm a carpenter, so.
Yeah, it's a half. You bet.
Or it's 0.5.
0.5 if you like that. Sure.
Yeah, you go the way.
What is that? What did you say?
This
MV?
MV. Yeah, so the mass
Velocity.
times the velocity, but
Square.
it's the square of the velocity.
What's that? That point? That's what that means.
That 2. That's what the 2 means. Is it's
The
square in.
two uppercase, yeah.
Yeah.
Yeah. So, and I don't like KE. I like E sub K. And we kind of had a conversation about that. If you would allow me to use E sub K instead of KE. Does that kind of sound familiar?
Book says, I don't know.
I will say this, that KE is defined to be the same thing as E sub K, and that PE is defined to be the same thing as E sub P. But this is what I'm going to use. So E sub K equals 1/2 times the mass times the velocity squared. Another way to say that is it's 1/2 times the mass times the velocity again. If it were velocity cubed, we would have 3 velocity terms.
So you're gonna can you
Sir.
you can take the you want us to figure out the squared initially? So that way it's 1/2 or 0.5 times the mass, whatever that is, and then you go ahead and you square the velocity and be done with it.
These are
It's algebra.
it's algebra, and so there's an order of operations.
Yeah. Which
What is it? Please excuse my dear Aunt Sally, right?
Yeah.
Does that mnemonic sound familiar to you? Please excuse, so
I'm so lost. right
please excuse my dear Aunt Sally. This is PEMDAS for order of operations. When doing a math problem, you start with the parentheses. If there's a parenthesis involved, you do the parentheses first.
now. Okay.
Then you do any sort of exponents, right? Raised to the power of 3 or raised to the power of 2 or whatever. And then you multiply, and then you divide. And after you've done all that, then you add and then you subtract. So that's when working a math problem, that's the process, the order of operations. So we don't have any parentheses. We do have an exponent
So you solve
because we have velocity squared, right?
2.
2, exactly. So let's plug in some numbers and see what happens. So
Like 1,000 times itself.
the mass is 1,000 kilograms, and the velocity is 5 meters per second, and we need to square that. So all I've done is I took this equation that we knew, that we got out of the book, and I plugged in some numbers. So 1/2 mv squared is right out of the book. Would you agree with that?
Yeah.
Okay. So my mass of the elephant we saw here is 1,000 kilograms.
So it would be
The velocity
1,000.
is v is the velocity. We saw that was the elephant was running at 5 meters per second. So we can say equals 1/2 times 1,000 kilograms. I haven't really done any work yet. What's 5 squared?
5 squared, 5 times 5 times 1.
5 times 5.
Times 5 times 5.
No, that's just 2.
Oh, okay.
Because it's
25.
5 times 5. It was 5 cubed. 5 times 5 times 5. 5 to the 4th. 5 times 5 times 5 times 5. So if it's to the 2,
It's just
5 times 5. That's exactly right. 10 to the 2 is 10 times 10.
Right.
17 to the 3rd, 17 times 17 times 17. So 5 times 5 is what?
25.
25. Interestingly, I need to square my units as well, but we won't worry too much about that.
Why did you
Right
split it into units?
I always carry my units with me whenever I go someplace. Even when I fly, I put them in my carry-on.
But the end thing is it's the velocity, right? Is what you're squaring.
Yes, I squared the velocity, and the velocity has units
And-
of meters per second.
Okay, meters per second. So you're solving the.
So I have to square, because I square everything inside the parentheses here, I have to square not only the number but also the units.
Right. Right.
Tell me what you're thinking, Clint.
I'm thinking this is going to be difficult for me. I need to get into the exact thoughts.
Tell me where I lost you.
Probably somewhere after we talked about your dog.
Okay. Welcome to my office.
You know, I just, I think I have issues remembering formulas to get all that. I'm understanding for the first time the letter association and all this stuff. The
Good.
M and the S
And all that.
and the E. You know?
Right?
I'm understanding that much, but I'm like, I've got some catching up to do.
This is a new world.
Yeah.
And luckily it's a 101 class. So even though we talk about some things that might feel overwhelming, just ride the wave, and I won't let anybody drown. If you keep swimming, this is sort of a general comment. If you keep, what do they call that? Treading water and doing the best you can, I won't let you drown.
Well, I appreciate that. I just need to get into those classes
Yeah.
so I can learn and catch up.
Yeah. Okay.
The basic. What's that? The math class. 208,
108
108. That
technical math.
that is all covered in there.
Yeah. Well, I don't know. I tested into all this stuff.
Yeah.
Did
You
you
know what I'm
test
saying?
out of that?
I haven't been in college in 7 years, man.
Well, I'm right there with you because it's been like 30 for me.
Yeah.
So yeah,
Okay, we're all coming from different places.
And we had started algebra, and then I moved, so I didn't even get to. I remember first 2 days I was lost. I was like, what the hell?
Yeah.
I tested into it though. I passed all the beginning math stuff to get to there.
Right.
Just
Right.
there's something
Well-
about this that it looks like a bunch of scribbles to me.
Okay. And I am confident that practice will increase your comfort level.
Yeah.
And so we can do as much practice as you want.
Absolutely.
So we started off with this question, what is the elephant's kinetic energy? And we recognized in the book that there's an equation for kinetic energy. We wrote that equation down. It's right here, 1/2 times the mass times the square of the velocity. And then we started using this information that we were given in the problem, and we started plugging it in, right? So the mass is 1,000 kilograms, so we replaced m with what it equals. The velocity is 5 meters per second, so we replace the letter with what it equals, making sure to square it. So now, using this order of operations, PEMDAS, please excuse my dear Aunt Sally, I see that the next thing is,
Oh, I do remember that. No.
look at that, see? Multiplication. So we're just going to kind of go through this list and multiply. 1,000, no, sorry, 1/2 times 1,000 kilograms is what?
1/2 times 1,000 kilograms?
Yes.
I couldn't tell you. I don't know.
be 500.
500. In other words, it's 1/2 of 1,000 kilograms.
Yeah, we just multiply it times
Multi-
0.5.
multiplication is always addition when it comes to
You're talking about exponents.
exponents.
And that's a true statement. When you multiply exponents, you do add those exponents. Do this. Do you have was that a calculator that you pulled out
No,
there?
it's this thing called MyScripter. I've been testing it out. I don't know if it's usable in your class.
Oh, I don't know either.
You
But
just-
type in,
You just write in.
okay, well,
I haven't figured out how to use it yet.
we'll try 1/2 times 1,000.
Okay, I don't know how to do halves
Can you do 1 over 2?
1 over 2. What would that look like to do?
Probably a 1 and then a line.
This way?
Sure, try that.
That didn't work. 1, 2,
Aha!
that
Okay, now times
times
1,000.
busted up screen.
Look at that, 500.
Okay.
Excellent. And Dan,
I just got a calculator.
you just did 1,000 over 2 or something like that?
Yeah, I just did my head.
Yeah, okay, I see. So I'm going to say 500. Now that doesn't mean we can drop the units, so I'm going to keep the unit with us. 500 kilograms times 25 meters squared per second squared. So what is 500 times 25?
500 times 25.
We're just multiplying these two numbers together.
Find that out. 1250. 12,500.
12,500, I agree with that.
Yep.
Now, I could sit here and say it's 12,500 kilograms times meters squared per second squared, but I'm just going to say joules. Because isn't kinetic energy expressed in units of joules?
I don't understand why you would just.
Why you would convert from one to the other so quickly like that?
Yeah.
I have an answer, but I don't know if you want to hear it.
Yeah,
Well,
sure.
isn't the relationship 1-to-1?
Keep talking, what do you mean?
Well, it's like certain things like watt to joule is the same. It's 1-to-1.
A joule per second,
Yeah.
yes. There is a relationship. 1 watt equals 1 joule per second. You're absolutely right. And it turns out that 1 kilogram meter per second squared times meters equals 1 joule.
Write the formula down.
Okay, but I'll do you one better.
Because I assumed that you're going to post this.
Yes.
Yeah. I love the formulas because that way I can.
Okay. Well, let me tell you what. Let's finish this problem first.
Because if you notice, I did this already, right? And
Yeah.
It's not correct, but I threw all the formulas in there so you have
Uh-huh.
it. So this is what I was thinking, Mr. Teacher.
Okay. Well, good. So we have an answer. This is the energy in joules, and I'll talk about how we go from one to the other, how we get to joules in a second. But one thing that I want to point out is the second question: what is the potential energy of the elephant when it's at the top?
At the very top, I don't know. It's got to be at least half, if not less.
If we assume that the elephant is running right here, and it gets up to the top of the hill and then stops, there is this 20-meter difference here. So we can say that all of the kinetic energy has been converted to potential energy.
Because the force is now going directly down.
The force is now going directly down.
Yeah.
That's
Before
correct.
that, but when the kinetic energy is that is carried alongside of the elephant as it's going forward.
You
or
could
is it-
say alongside, yeah. It's in the direction of the elephant's travel.
But it's not actually the elephant itself, because that would be its mass times whatever it's running into,
Yeah,
right?
times its acceleration.
Well, once you get past the acceleration point, and you just got the traveling, because that's what you're talking about when you're talking about the kinetic energy. You're talking about the energy that exists while it's traveling,
Mm-hmm.
not so much the acceleration and not the stopping at the top,
Right.
but just during the trip.
Yeah, it's called the energy of motion. Kinetic energy is the energy of
Yeah.
motion.
So
And it's based on its speed. Yeah. I mean, largely, if you look at the equation, wherever it is right here, you can see that it's largely based on that velocity term, its speed.
Yeah.
So we could say that the potential energy is equal to 12,500 joules as well. Now, Dan says, please prove to me that those units are the same.
Well, it's just put a ledger down saying that you get your EP
Oh my goodness, I don't know what just happened.
1200 is equal to the same amount of joules. Therefore, if I come up with the same kind of situation next time, then I'll know what the thing is.
Well, I can tell you that 1 joule equals 1 kilogram meters per second squared times meters. And I can bring these two meter terms together to get meters squared per second squared. And that comes from the fact that work equals a force applied over a distance.
Right.
And force is expressed as mass times acceleration. So we have mass times acceleration, times distance.
Right.
And that mass is expressed in terms of kilograms. Acceleration is expressed in terms of meters per second squared. And distance is expressed in terms of meters.
I love this physics.
There you go, Daddy. That's all about you.
Yeah.
Do you want to trust me that if we use these numbers correctly and we talk about kilograms for mass, that we'll end up with joules?
Yeah, I'll trust you.
I think at this point a better way to proceed.
Yeah.
Well, no, I just like seeing the formula. That's
Yeah. So that's the derivation.
That's fine.
Are we allowed to use tools like this?
I would encourage you to use tools like that. If that doesn't work for you, I want you to use something else though.
What?
I don't know.
Scientific calculator?
I don't
got
know.
one of those downloaded too.
Okay. Whatever. You know what? This thing is sufficient for your purposes.
Yeah. I don't know. I'll show you what else I have.
I use this, but that's just because, I have
It's
a leftover
big.
from college.
I have everything you need.
I have that exact same app on my phone and I use it all the time.
Yeah, I'm thinking about buying it.
Why? The free one's good.
Yeah, I know, but it kind of keeps going with you with every other phone that way.
Oh, does the free one not?
No, you have to go find it and download it again.
For free?
Yeah, and I'm gonna go
Okay.
I'll get another trip on the 11th. I get another phone on the 11th. So,
Clint, you're going to rock the house in whatever way works for you.
yeah.
I just, don't give up.
Yeah, no, I'm not.